When they first told me that we were going to get a pipe and put it inside our existing pipe, we were going to push and pull it through, 3 miles, I thought they were crazy.
We did a routine industry operation and detected numerous examples of pretty significant corrosion in the flow line.
The pitting has continued at a much more rapid pace than anyone had anticipated.
The stakes were high to get this fixed in the most expedient way possible.
If we no longer have this pipeline, we can no longer produce Spy Island, which is half of our production.
The combination of PGI, Con-Am, and Mears, who are all sister companies, one of the benefits we saw that in contractor selection was that the coordination between these companies would be good.
Our portion of the job scope is to fabricate the pipeline itself as a 10-inch line and come up with a method to bring the pipeline to Mears Group to where they will actually be threading the pipeline through an existing pipeline. So it will be a pipe-in-pipe project that we're working on here for our client.
This really had to work, and we were only going to get one shot at it.
These work conditions are very extreme. With the wind blowing, with the rain, with the sleet, with the snow. Out here, the weather can change in the drop of a hat. So we're dealing with all kinds of different adverse conditions.
Working on the North Slope definitely has its challenges. The environment changes quickly. It's very unpredictable. Right now it's snowing. Yesterday it wasn't.
This job has some of the most technical challenges that I've run into in all my years in construction. The pipeline goes from the shore 3.5 miles subsea pipeline out to a man-made island and then comes out on the island. And the pipe goes into the ground at 16 degrees, goes across the seabed buried below the sea, and then up the other side about 16-degree angle. So it makes for a little bit of a challenge trying to get a new pipe built and configured and into that old pipe.
Previously, we had a pipe-in-pipe arrangement. We had an inner pipe transporting hydrocarbons, and we had an outer pipe that served as secondary containment and also a leak detection methodology. Our repair concept was actually to sleeve the inner pipe with a third pipe, generating a pipe inside of a pipe inside of a pipe, with the second pipe being the corroded one. It's easy to say, and it's easy to draw up on paper. It's difficult to achieve in the field.
This hasn't been attempted before. I know they've put pipe in pipe, but not to this extent. The major constraint and challenge is the amount of real estate we have.
We were constrained to the north by the Beaufort Sea, to the south by the tundra, to the west of us was a U.S. Air Force radar installation, and to the east, access roads.
If we could weld out 3.5 miles and then just feed it, that'd be phenomenal, but we don't have that luxury here.
We had a significant engineering and construction challenge to make this pipe bend 90 degrees and then downwards 16 degrees to enter the pipeline at the right angle without overstressing the pipe, also in an Arctic environment where we're seeing temperatures as low as minus 20 degrees Fahrenheit.
We were contracted to bring up a thruster and a directional drill rig. Basically, we inserted drill pipe from SID Island to the OPP side. Then we would go use the thruster and the drill rig to pull the 10-inch back across.
The large thruster machine will actually push with a force of 750 tons. It grabs the pipe and grips it and then pushes it into the bulkhead. Our pull cable is heavy 6.5-inch drill pipe that will be pulling. So we'll be pushing with the thruster, pulling with the HDD machine out on the island. And that's how we're going to get this pipe all the way across. Price Gregory built the pipeline on the beach in 960-foot strings. We do tie-in wells as we're pulling it through. After Mears gets the pipeline pulled and pushed through, then Price Gregory comes in and does the tie-ins at either end and then the hydro test of the whole system. So that's a big step. Once we get the hydro test done, then Con-Am will go back in and finish all of the pipe rack piping that we have to put back in place and restore everything to its original condition so that the plant is ready to start back up.
It's a challenge that I haven't been a part of before, and to my knowledge, no one within Price Gregory International or any of our sister companies associated with this project, Con-Am or Mears Group, has either. We're having to do a lot of design work as we go, which of course creates its own obstacles, but obstacles are what makes this job fun.
It made a lot of noise when we were pulling it, you know, and we had a lot of concerns there. The rollers, were they built strong enough? What were they going to do in real cold weather if things were going to go apart? Because we had to pull 3.5 miles through those roller boxes.
I was there when the pipe landed. We had to visually verify it, so we cut open the breakout spool and cut a window in it so that we could see it. It was right on the money.
The moment that this pipe got through was not only exciting, but it was also a sense of achievement of what amazing people can do when they set out to do something.
It would be very difficult if there were outside companies. The fact that Price Gregory and Mears were Quanta companies made it much easier to come together contractually as a group because we worked together in the past and we had the same parent company.
The Con-Am slogan says, "We'll find a way." We have found a way, created ways to beat all the challenges.
From the day that Con-Am, PGI and Mears walked onto site, they have shown us that they are safety leaders. It's taken a lot of work, it's taken a lot of effort, but everyone has stuck together, worked together to make sure that we have been successful.